So, like the assignments that I gave you yesterday, the first one was pretty easy. It was like, what are your undefined terms? And it's basically whatever makes the bottom zero. The second one was, find your horizontal asymptote, and that was, top and bottom. That was, where you most important term on top, most important bottom. We talked about top heavy, bottom heavy, and balance. And the third one was a little tricky. It was, how do you find your vertical asymptotes? And the vertical asymptotes and undefined terms weren't exactly the same. Like undefined is simply whatever makes the bottom zero. A vertical asymptote is whatever makes the bottom zero after you've simplified it. So there's something going on with some extra things, and that something is what we're going to be talking about, part of one of the things we're going to talk about today. So yesterday was about the asymptotes. Today it's about some important points. So the first important point is, I'm going to write over here, and it's going to be the y-intercept. Okay, so yeah, like how do you find the y-intercept? Well, how you find the y-intercept is you set x equal to 0, and if I look at this particular problem, here, I need to erase this. If I go back here and I say, well, how do I find the y-intercept? Well, I plug in 0 for x, and when I plug in 0 for x, this is going to give me, what's that, 2 times 0 plus 4 over 0 plus 3, which is going to, well, those go away, that gives me 4 over 3. I just found out my y-intercept is 4 over 3. And if it looks like that seems like a pretty easy procedure, the good news is that's as tough as it gets. Finding the y-intercept is always the easiest thing to do, because when you plug in 0 for x, and anytime you plug in 0 for x, things get a whole lot easier. Now, after you look, like, you could almost think about this. This goes away. If you sort of cut out the middle person, you've got y is equal to 4 over 3, right? We just found the y-intercept. Now, unfortunately, Delta Math isn't going to accept this as an answer for your y-intercept, and I'm not going to accept y equals 4 over 3 as a y-intercept. And the reason I'm not going to accept that is a y-intercept is a point, meaning you have to give me a coordinate. It's not enough to say find the y-intercept and you say y equals 4 over 3. You've got to give me a coordinate, meaning, here's your y-intercept. Right? I need an x part and a y part. Well, we know the y part's 4 over 3. I need the x part. Well, we know the x part is 0. So when you are asked to find a y-intercept, right, you can't just give me the y value. You have to give me a coordinate, meaning you have to also give me the x part. In fact, all of the points that we're going to talk about today, you've got to give me a coordinate. You can't just give me like a particular value. I need the x and the y part. Right? Let's look at the next problem. For this one, if I want to find the y-intercept of this, plug in x equals 0. And if I plug in x equals 0, well, that's going to give me 2 over 0 plus 3, which is going to give me 2/3. So I just found out that my y-intercept is going to be at 2/3, but I can't just say y equals 2/3. I have to give a coordinate. And when I give that coordinate is going to be the point 0, 2/3. Okay. And if just to make sure everybody's clear, that's as hard as it gets, even if the numbers are really ugly. Even if it looks like it looks like a challenging problem. Like if I give you y is equal to x squared minus x minus 6 over x squared plus 6x plus 8. Okay? This is a more complicated rational function. Okay? But to find the y-intercept isn't any harder, because all you do, plug in 0 for x. And when I plug in 0 for x, that's going to give me, well, that's a 0, that's a 0, that's going to be minus 6, that's a 0, that's going to be 6 times 0, which is 0, and that's an 8. And so these go away. I'm just left with negative 6 over 8, which reduces to negative 3/4. So I found my y-intercept is going to be at negative 3/4. But I need to write it as a coordinate, so my y-intercept is going to be 0, comma, negative 3/4. And that's as hard as it gets. And notice this, finding the y-intercept for this thing isn't that much harder than finding the y-intercept for this. That's the good news, right? So there are three types of points that we're going to find today. The first one is, how do you find a y-intercept? And how do you find a y-intercept? Plug in 0 for x, figure out what y equals, and make sure to write it down as a coordinate. So you have the x value of 0 and the y value of negative 3/4. So one of the three things, find the y-intercept. Okay, next. The next thing we need to find, well, if I talk about y-intercept, then probably need to talk about an x-intercept. And so how do you find an x-intercept? Oh shoot, I erased that. I'll have to put that back up. So how do you find x-intercepts? Well, to find a y-intercept, you set x equal to 0. To find an x-intercept, you set y equal to 0. So if I want to go through this and I want to find my x-intercepts, I set y equal to 0, so that's going to give me 0 is equal to 2x plus 4 over x plus 3. Now I know it's been a month, but how do you set a fraction equal to 0? Well, the only way a fraction equals 0 is if the top part equals 0. So if I set this whole thing equal to 0, really all I need to worry about is setting the top part equal to 0. And if I set the top part equal to 0, now when I solve, subtract 4 from both sides, so negative 4 is equal to 2x, x is equal to a negative 2. And so I found my x-intercept. Well, same story, same kind of thing happens now. The way you find your, if I'm looking for an x-intercept, I need a coordinate. I don't just want x equals negative 2. So if I'm going to write down my x-intercept has to be a coordinate. Well, I know the x value is negative 2, and I know the y value happens to be 0. Now, while I did say that we're not interested in graphing, like I'm not going to make you graph anything today, I still want you to look at what's going on in this. Okay. So let's sort of recap the information we have from this, because I already made you do part of this. Let's see, we found out we had a vertical asymptote at x equals negative 3. We had a horizontal asymptote at y is equal to 2. We have a y-intercept at the coordinate, what is that? 0, comma 4 over 3. So here's our information, right? And this is combined with what we did yesterday and what we started with today. It's pretty easy to find vertical and horizontal asymptotes. For y-intercept wasn't so bad. The x-intercept, actually I want to modify the instructions. X-intercept, you set y equal to 0, or because it's going to be a rational function, we just go ahead and set the top equal to 0. So you set whatever the top is equal to 0. So I'd like to see what a picture of this looks like. So I bust out my high-tech graphing calculator, and let's see, that's going to give us a 2x plus 4 over x plus 3, and a graph. And hopefully this picture makes sense with this information. It says we have a vertical asymptote at negative 3. So if I look at this, there's our vertical asymptote at negative 3. It says we have a horizontal asymptote at y equals 2. So if I draw this in, I don't know why I've been dealing with a blurry picture all day. Okay. I've got my horizontal asymptote at y equals 2, and if you look, right, vertical asymptote, this is behaving the way it's supposed to. It's going all the way down on this side, it's going all the way up on this side. As far as horizontal asymptotes go, as I go to the left, this gets closer to y equals 2. As I go to the right, it also gets closer to y equals 2. Now, it says your y-intercept is at the coordinate 0, 4 over 3. Well, 4 over 3 is a little bit bigger than 1. And if I look at this, where does it cross the y-axis? Notice it crosses the y-axis at a spot a little bit bigger than 1. My x-intercept, where it crosses the x-axis, crosses at negative 2, 0. And so if you look, it crosses at negative 2, 0. And so what I have is this picture is representing this information. Now, in the very near future, you're going to have to draw this picture, but not today. I'm just making sure we can identify the x and y intercepts, right? And I just want to make sure we understand what it looks like on a picture, right? Well, so now, let's look at the other example that we have, the other problem that I gave you. The other problem I gave you was y is equal to 2 over x plus 3. And, all right, so from here, let's see, we already talked about it having, we had a vertical asymptote at x equals negative 3, it had a horizontal asymptote at y is equal to 0. It had a y-intercept. We already had our y-intercept at the coordinate 0, 2/3. And so now let's bring up, how do we find the x-intercept? So, how do you find the x-intercept? Well, the way you find the x-intercept is you set y equal to 0, or since it's a rational function, just go ahead and set the top equal to 0. So I'm going to do that, right? I set 0 is equal to 2 over x plus 3. Although the shortcut is you just set the top equal to 0. So if I set the top equal to 0, that's weird, right? That doesn't make sense. See, when I set the top equal to 0 here, I had an equation I could solve. But over here, when I set the top equal to 0, I get 2 equals 0. That's just wrong. What does that mean? Well, what it means is there's no x. That means whatever we're looking for, it doesn't happen. So in this case, because we get a sort of something that's not true, that means we don't have an x-intercept. So if you're ever asked to find an x-intercept and there isn't one, which is like in this case, you just get to say none. All right? Well, more importantly, what does this look like, right? We've got our, in the previous problem, we got our information. We got to see what that picture looks like. So what does this look like? What does this look like with this information? So I pull out my high-tech calculator and I type it in. All right, so it's just going to be 2 over x plus 3. What? Oh, that was not nice. So 2 over x plus 3. No. Sorry. Okay. So now we have our picture. Now I've graphed this. First, vertical asymptote at x equals negative 3. That hadn't changed, right? So we still have our vertical asymptote. As we go down, this thing, as I come from the left, it goes to, the vertical asymptote, it goes all the way down. This goes all the way up. Says you have a horizontal asymptote at y equals 0. And if we look at this, here's y equals 0. Notice how the graph gets really close to 0 this way, and the graph gets really close to 0 this way. This says you have a y-intercept at the point 0, 2/3. Well, 2/3 is a little less than 1. And if I look at my picture, that's 1, a little bit less than 1 is right here, so that my y-intercept makes sense. And this says I don't have an x-intercept, which means I don't cross the x-axis. And if I look at this picture, you ask yourself, does the graph cross the x-axis? And it's just getting close. No, it doesn't cross. Just getting close, it doesn't cross. And so this is what it looks like when the graph doesn't cross the x-axis. And if it doesn't cross the x-axis, you're not going to have an x-intercept. Now, what? Yes?
For horizontal asymptote and vertical, does it ever like touch that number? Like, will it ever?
Great question. Vertical, no. Verticals are absolute walls, they never touch. Horizontal, when we start doing some more complicated things, they can. Right? And those are questions that are going to be answered when we actually start graphing.
Okay.
Yeah. Right now, I'm taking it slow. We're literally going through this. I'm going to talk a whole lot today, but my main goal is we're just going to talk about parts of the graph and then get that down before we start graphing.
Okay, thank you.
All right. So, there we go. Right? How do you find the y-intercept? Set x equal to 0, and no matter how ugly it is, when all those x's go away, it ends up being pretty easy. How do you find the y-intercept? How do you find the x-intercept? Set y equal to 0, or just set the top equal to 0, and that'll give you your x-intercept. Sometimes you don't have one, which is what happens here. Now, here's the problem. I like delta math, but delta math puts some tricky questions. They didn't have anything really tricky for a y-intercept, so I don't have to do a whole lot of explaining on that. For x-intercepts, they've got some tricky stuff. And to answer the tricky stuff, we have to go back. We have to talk a little bit about the difference in the two assignments that I gave you yesterday. The first assignment I said was find all the undefined terms, and then another assignment was find the vertical asymptotes. And we had a big discussion about, you know, how do you find vertical asymptotes and undefined terms? Well, you set them both equal. You set the bottom equal to 0. But you know, just because the bottom equals 0 doesn't mean it's a vertical asymptote. So it's something weird's going on. And so today we're going to talk about that weird thing, right? And the way we're going to talk about that weird thing, is with a certain example. And so here's my little example, and you don't need to write this down. In fact, I would. That's x squared minus x minus 6 over x minus 3. This is a very weird problem. This is a weird problem because this should be very complicated. And the reason it should be complicated is rational functions, they've got asymptotes, they've got stuff goes off to infinity. You have all these swoopy lines. And so, now granted this doesn't have a horizontal asymptote because it's top heavy, but I'm interested in the graph. So I'm going to go up here and I'm going to go and say, type my graph in. So this is going to give us x squared minus x minus 6 over x minus 3. And I'm expecting when I graph this for it to be really complicated. But it's not really complicated at all. Like, what should be really a mess simply looks like a line. Now, for those of you that remember from yesterday, the difference between if you had undefined terms and you had x-intercepts, if the only thing that created vertical asymptotes, the only thing that created vertical asymptotes was if what was undefined after you cleaned it up. All right, so I'm going to go through the cleanup process. So our cleanup process here is, and we factor, and so this gives us y equals x minus 3, x plus 2 over x minus 3. And we notice that the x minus 3's cancel, and we're left with y is equal to x plus 2. Okay? So what looks like a really ugly graph after we clean it up ends up with y equals x plus 2. And if you think about it, this graph Looks an awful lot like this, doesn't it? This is just a line, has a y-intercept of 2 and a slope of 1, which is what happens here. It has a y-intercept of 2 and has a slope of 1. And so what I thought was going to be a really complicated graph just ended up being a line. Well, sort of. There's something going on here. First, what I need everybody to understand is this black equation and this green, this black function, this green function, are very, very similar, but they're not exactly the same. And here's why. In this black function, we have an undefined term. We have an undefined value, meaning I don't care that it canceled out, but when I looked at this, x cannot equal 3. This original function says that x cannot equal 3. And believe it or not, this picture shows us that x cannot equal 3. I always use, anytime I know I could use Desmos or some of the other, other online calculators, but I like using the old graphing calculator because when I graph this, I don't know if any of you noticed this, but when you graph this line, I don't know if you noticed there was a gap here, right? And that gap is actually there on purpose. It's not because there's a dead pixel, although sometimes I try to play it off as a dead pixel. The reason there's a gap here isn't because of a dead pixel. The reason there's a gap is that x can't equal 3. See, that gap is not random. That gap is exactly at x equals 3. When x equals 3, the function doesn't exist, so we get a gap there, meaning there's something. In fact, it's not called a gap. Its technical term is called a hole. And that's the third element today. We talked about y-intercepts, talked about x-intercepts, and the tricky part of today's lesson is I need to talk about a hole. Okay? So what causes a hole and how do you find them? Well, what causes a hole is anytime stuff cancels. Yesterday, the difference between an undefined term, when you had undefined terms, some undefined terms are vertical asymptotes, some undefined terms weren't because they got canceled. Those things that were undefined terms that got canceled were holes. So anytime you have a rational function, when the bottom equals 0, it's going to be one of two things. It's either going to be a vertical asymptote or it's going to be a hole. Yesterday we talked about the vertical asymptotes. Today we're going to talk about a hole, right? So what causes the hole is whenever something cancels. Now, in looking at this, notice this canceled, like x can't equal 3. What makes the bottom 0 in this case is x equals 3. So we could say that we have a hole. We have a hole at x equals 3. And we could say that. But here's the problem. The problem is everything that we're talking about today is a point. It's not an x value or a y value. It's an actual coordinate. Like I made a big deal about when we talk about y-intercepts, I need a coordinate. When I talk about x-intercepts, I need a coordinate. When I talk about holes, it's not enough to tell me it's x equals 3. I need a coordinate. Right? And how do you find that coordinate? Well, how you find that coordinate, and this is part of it that's kind of tricky today. If you've got an x value, you need a y value. So the way you get your y value is you plug it back into a function. If you plug it back into the original function, you're going to get something called, it's going to be 0 over 0, which that's something that we discuss in calculus. It's called an indeterminate form. We're not worried about that at all. But all you need to know is you don't, if you ever get 0 over 0, that means you don't know what's going on. So if you take that x equals 3 and you plug it back into the original function, it's not going to give you anything useful. What you have to do is take that x equals 3 and plug it into the simplified function. And if I plug that x equals 3 into the simplified function, I'm going to get y is equal to 3 plus 2, or y is equal to 5, meaning I just found out my hole is at the coordinate 3, 5. And See how that compares to my picture? Remember I had a hole up here? It's over 3, up 5. This is telling me exactly where my hole is. So, how do you find a hole, right? First, you have to clean stuff up, right? Whenever you cancel, like you factor, and anytime you cancel, that's going to create a hole. Whatever value of x, like if x minus 3 cancels, that means we're going to have a hole at 3. Once you find the x value, then you have to plug it back in to something to find the y value, and you always plug it back into the simplified version to find the y value. And then that gives you where your hole is. So with that, now we need to do a couple more examples. I want to go back to this complicated thing. So let's say I give you y is equal to x squared minus x minus 6 all over x squared plus 6x plus 8. We've already talked about this. I already made you find the vertical asymptotes. I made you find the y-intercept. But I didn't have you find the x-intercept, right? And the reason I didn't have you find the x-intercept is, well, we're about to see. So, given this, this is about as ugly as it gets, and you're asked to find x, y, x-intercepts, y-intercepts, and holes, the first thing you do is you factor. And so now I factor this. This is going to give me x minus 3, x plus 2. And on the bottom, I'm going to end up with x plus 2 and x plus 4. And what I would like everyone to do, just to see if you're paying attention, maybe wake you up a little bit, is I want you to type in what x value gives you a hole. So in the comments, I want everybody to type in what x value is going to give you a hole. All right. Now, I don't know what I did. Maybe I did a better job explaining it or something. But first period, I said, what gives you a hole? And I had about half the people, half and half. Some were saying -4, some were saying -2. Everybody here is saying -2. So looking at this, right? So if whatever cancels out is going to cause a hole. So we see this cancels out, and so we know that we have a hole at x equals -2. Now, here's a problem, right? The problem is if I say, what's the hole, you have to give me a coordinate. You just can't say x equals, -2. You can't just say x equals -2. You've got to give me the coordinate. And how you give me the coordinate is you go to the cleaned up version. So our cleaned up version of this is, let's see, x minus 3 over x plus 4. And from this cleaned up version, we can find out where our hole is. Right? And means I've got to plug in -2. So if I plug in -2, that's going to give us -2 minus 3 over -2 plus 4, which is going to give me -5 over 2. So that means I have a hole at -2 comma -5 over 2. So I've identified the hole. Now let's answer some of the other questions. One of the other questions we've already answered on this was, what's my y-intercept? And the way you find your y-intercept is you plug in 0 for all the x's. And if those go away, I'm left with -6 over 8, which is going to give me -3 over 4. And I need to make sure I have a coordinate. I've identified my hole is -2 and -5 over 2. Next thing I want to do is, how do I identify my x-intercept? And here's something that you've got to pay attention to. How you identify your x-intercepts is you find your x-intercepts in the cleaned up version. You can't find your x-intercepts up here because, remember, how you find your x-intercept is whatever makes the top 0. Well, in this case, like a -2 would make the top 0, but that's part of the whole, so we don't need that at all. So, so when you're trying to find, whenever you're trying to find x-intercepts, the first thing you have to do is clean it up, establish if there's a hole or not, and then find your x-intercept from the cleaned up version. So, in this case, for this problem, what is my x-intercept? Everybody type it in. I like that. Someone put a coordinate. Remember, your x-intercept is not just a value, it is a coordinate. So we set the top equal to 0. And if I set the top equal to 0, right, when I set the x minus 3 and set it equal to 0, we find out that x is equal to 3. So we know that the x value is 3, and then the y value is 0. So we find our x-intercept is a coordinate 3, 0. And to be, and you'll be, Delta Math will be pretty good about making sure you have to write it as a coordinate, because if they gave you this problem in Delta Math and they said, what's the x-intercept, and you said x equals 3, either it would mark it wrong or it'd say your answer has to be in a coordinate. So they're going to make sure you get the right answer. All right, so today we talked about how do you find a y-intercept, how do you find an x-intercept, and for the most part, finding x-intercepts is you set the top equal to 0. But there are a couple of tricky questions where you've got to worry about holes and things, so you've got to clean things up. And to be honest, I wish Delta Math would have stopped there, right? Because I think that's kind of tricky. I would really rather them say, okay, here's an x-intercept, just find x-intercept, that's fine. But they kind of mix x-intercepts and holes a little bit, so you have to worry about this. Oh, actually, one more thing. Delta Math does. Sometimes they'll say find a hole, right? And they'll give you this. If I give you y is equal to x squared minus x minus 6 over x squared minus 16. So if I give you this problem and they say find the holes, that's fine, right? So, like to find a hole, you want to simplify things. And so I go through it, and I say, well, that's going to give us x minus 3, x plus 2, over x plus 4, x minus 4, right? And the way you find holes is you look for something to cancel out. And if you look at this, you may notice that nothing cancels out. Okay. Since nothing cancels out, since nothing cancels out, that means no holes. So in part of your, like in the assignment that says find the holes, there are going to be some times where if nothing cancels out, you don't have a hole, so you don't have to worry about it. Now, that's not the super tricky part. That's just something I want to make sure everybody understands. The very, very tricky question that I wish Delta Math didn't have, but it's going to show up. You're going to have one question that's this tricky question, and I need to address, make sure we know how to handle it. And here's what it looks like. And after that, I'll take attendance and you can get started. Let's say I give you y is equal to x squared plus 2x plus 1 over 3x plus 3. And your job is to find the x-intercepts. Right? You're going to get a question like this, and I want to make sure you're ready to answer it. So, like some of the x-intercept questions are, you just factor the top, set it equals 0, and done. But what you should do first on x-intercepts is clean it up. So to clean this up, well, let's see, we're going to factor it as x plus 1 times x plus 1. That's going to give me a 3 and an x plus 1. So, see, when I look at this, well, a couple of things I notice. One is, I see that cancels out so that I have a whole at x equals negative 1. Okay? But I have to write my answer as a coordinate, so I'm going to clean this up. So when I clean this up, I get y is equal to x plus 1 all over 3. So I'm going to plug negative 1 in. Negative 1 plus 1 over 3 gives me 0 over 3, which just gives me 0. So I have a whole at negative 1, 0. Is everybody okay that we have a whole there, right? That works just like all the other other problems. Like, you find the whole, right? You simplify, whatever cancels out, that gives you the x part of the whole. You got to find the y part, so here. But my original question wasn't to find the whole, it was to find the x-intercept. And how you find your x-intercept is you look at the cleaned up version, and you set the top equal to 0. Well, fine, that seems pretty easy. I'm just going to set the top equal to 0. So if I set x plus 1 and I set that equal to 0, I end up with x equals negative 1. And so I find out I have an x-intercept at negative 1. And so I end up with an x-intercept at negative 1. But I also need the y value. Of course, the y value is going to be 0, and so I do this. And now I have a problem. See, a hole means there's a hole. There's not a dot there, there's a hole. But an x-intercept is a dot. And I have a conflict because the first thing says I have a hole at negative 1, 0, and the x-intercept says I have a dot at negative 1, 0, and they both can't happen. And so the answer is there's a hole, right? And if there's a hole, there can't be a dot, meaning there is no x-intercept. So you will have one question where if you find there's a hole, and that hole happens to be the same place that there's a dot. You've got some connectivity issues there. So, all right, so that being said, I need everybody to start the delta math. The order was, I think the order I set it up was, first thing you're going to do is y-intercepts, then you're going to do